Number 23 here is asking for the integral from 1 to 27 of, let me not read it off here, it's a fraction with variables on both the top and the bottom. That's messy, guys. It makes it tough to do that. But what I want you to notice is, yet again, I feel like this theme is going to show up a lot here in the middle of this chapter. It's a polynomial numerator divided by a monomial denominator. And what that means is we can split this thing up into that fraction divided by that fraction. So I'm going to rewrite this as an integral from 1 to 27 of t over the square root of t, gotcha, and then a plus 1 over the square root of t, all taken with respect to t. Now, before we're ready to start anti-differentiating, we're going to rewrite each of these terms now. This is t to the first divided by t to the 1/2. So we subtract the exponents, and 1 minus 1/2, we get t to the 1/2. Plus, well, this one could just be rewritten right here. That's a t to the 1/2 in the denominator, which means we've got a t to the negative 1/2 right there, and that's the integral we're taking with respect to t. So, okay, let's get on it, guys. Let's anti-differentiate. So we're going to have a t right here. Raise your power by 1. That's 3/2, and then divide the old coefficient, which was 1, by the new exponent, 3/2. 1 divided by 3/2 is 2/3. And then what? Plus, you're going to have a t here. Raise your exponent by 1. So negative 1/2 plus 1 is a positive 1/2. And then divide your old coefficient, 1, by your new exponent. 1 divided by 1/2 is a 2. So there's your antiderivative, all of which is getting evaluated from 1 to 27. Now, as I'm looking at this, that is really, really interesting. I have a feeling, guys, that in problem number 23, this did not work out the way that somebody intended it when they were writing this problem. What is significant about 27 is that it's a perfect cube. So it would have been a cool number to put in here if we were dealing with cube roots right here. But we're not. We're dealing with square roots. And that means that the square root of 27, while it exists and it's a real number, it's not rational. We're going to end up with a pretty ugly answer to this. And I just feel like when somebody wrote this problem, they probably ended up with something different than what they had in mind. But regardless, let's dive in and see what we got. Putting in the 27 first, guys, this is going to be a 2/3 times, 27, let me just write this out, 27 to the 3/2 power, plus a 2 times 27 to the 1/2 power. Ugly. Minus, now this part works out okay, and I bet it's because 1 is both a perfect square and a perfect cube. We end up with a 2/3, and guys, I think we can do this in our head. 1 to the 3/2 power is just 1, plus 2 times 1 to the 1/2 power, that's 1 as well. Let's see what we can do to clean this up here, guys. Okay, 27 to the 3/2 power. So what I'm kind of hoping people know is that any number, like x, raised to the 3/2 power, well, what that becomes, everybody, is the square root of x cubed. And that means that x cubed right there is x squared times x. And the square root of x squared, that can be pulled out in front, you just end up with x multiplied by the square root of x. Any number to the 3/2 power is just, let's write this out here, the 2/3 is just going along for the ride. Any number to the 3/2 power is that number times its own square root. X times the square root of x. Okay? And then plus, we've got a 2 times the square root of 27 right there. Minus, all right, that's 2/3 plus 2. All right, so that's going to be 2 and 2/3, and on the next step, I'll probably make that an improper fraction, but I don't want to get ahead of myself. All right, let me, come on, scroll this down a little bit. All right, gotcha here. Okay, and let's see what we can do. Ugly, but tolerable. 2/3 times 27, that we can do. 27 divided by 3 is 9, times 2 is 18. Ooh, And the 27 right there, guys, that can be simplified. That's 9 times 3. Take the square root of 9 and bring it out front. So that's 18 times 3 root 3 plus the 2 just tags along, and we just did this. The 27, again, is 9 times 3. You bring a 3 out in front. So 3 times the square root of 3 minus... Oh, yeah, this isn't going to combine with anything right here. So you could leave that as 2 2/3 or make that 8/3, whatever strikes your fancy. What's going on here? 18 times 3 is 54 root 3, plus 2 times 3 is 6 root 3, and then minus 8/3. So those terms, at least, can be combined. That's going to be a 60 root 3, and then a minus 8/3. That can't be cleaned up any better than that, guys. I'm going to look at the solutions manual real quick here. And what do they have? 60 root 3 minus 8/3. Exactly the same way that I've got it written right there. So I'll say again, I'm pretty certain that this problem did not work out the way that its writer intended, but we were able to come up with an answer. I would definitely tell you guys, though, don't panic if that problem confused you a little bit with the level of detail that it required, because I don't think most of the problems you're going to see here are going to be that messy in terms of the evaluation with fractional exponents. So that's number 23.